Okay, so per everyone's request, I am going to make a very hastily made how-to video, including some measurements and how-tos for this panning zombie that seems to be getting a ton of attention, which I really appreciate. Okay, so the first thing I'm going to start with is the items you're going to need besides the PVC and the motor. Here is Spider Hills PropWorks. There are 3 things on here that you will need to do this the same as I did it. I will point to them. 4 of these elbows. Okay? They bolt down tightly for making posable props. Or, as I did, I left them loose. And in between here, you can see there's a small gap. Maybe you can't see right here. And there is a large fender washer in between there, because there are serrated edges in there, and if you don't leave a gap and put the washer in there, the serrated edges will just keep rubbing against each other even if it's not tight, and it just makes everything really choppy and probably eventually will destroy the hinges. So you need 4 of those. The other thing you need from Spider Hill is, on the video card, you can see it right here, right there. These bases. Okay? Those take the place of these bases, which I found on some random website someplace, because Spider Hill was out of those, because I waited until September to get it last time I needed them. So you need 2 of those. 1, 2. Okay? There's a short piece of PVC there, maybe 1 inch long, that connects to here. Okay? These elbows have slots here. So when you're building stationary props, you can just put a screw in there, tighten it down, and then it makes them really easy to adjust. These are awesome, awesome things to have for building stationary props, moving props. The only problem is, if it's really a problem, is they only come in 1 inch diameter for PVC, where usually I use 3/4 inch just because it's smaller and easier to work with. But for this I use 1 inch and 99%. Okay, the other thing you're going to need from Spider Hill is this item here. I know it's hard to tell, but it's actually a pivot. The pipe goes in here, okay, the PVC goes in there, and then this PVC pipe just slides through here. So it rotates in there, because you can't tell, but when this arm here is rotating back and forth, it actually goes up and down a very little bit because of the geometry of the arms. So to alleviate any stress, I had 2 of these. So this just slides through here. Just a little bit of rotation there, okay? And then I put the caps on there and a little screw right here to stop it from sliding too much back and forth, okay? Hole through here, hole through here. 3-inch bolt, 1/4 inch. One of the keys to making this whole thing move tightly and smoothly is all the holes are 1/4 inch, the bolt is 1/4 inch. Don't wallow out any of the holes, because you want the bolt to move freely, but not to move around loosely inside the hole. That's why you get the herky-jerky motion on some of these animatronics. Okay, so those are the things that you will need that are not purchased at your local hardware, Home Depot, Lowe's, whichever. All right, so some general, very general, believe me, I was winging it the whole time, just grabbing pieces that I had and just cutting them. The back end piece of PVC is about 12 to 13 inches. Okay. The height of this pipe, which is obviously simulating a calf, is about 14 to 15 inches. Okay. There's a very small piece of PVC in here to put this on. Okay. So you can put the T here. You build this little shelf or ledge or bracket. Believe me when I say this was completely winged. I did not cut them. I just grabbed two pieces that were approximately 7 inches long. 7 inches long for the cross beam here. Okay. That's it. So 7 inches, 2 90s. You need a T and a T. These pieces down here, which will be the calves and ankles, it doesn't matter how long they are. I'll get into this big thing and the weight and how to hold this thing steady, because I've discovered that if you don't have this weight, this thing will fall right over. So there's a downfall of the whole operation. But I am probably going to run pieces of rebar up through here. I'll drill a hole in the bottom of this one, run a piece of rebar up here, so it'll be solid. So that's that. These were just here to help stabilize it when I was building it. Those will come out and just put some 90 degrees down here. Run it, like I said, run a hole through the bottom to run a rebar up. Or if you're going to be running yours on the ground, you can just put sandbags or maybe a piece of wood on the bottom and bolt it through. Whatever works for you and whatever application you're going to work with. So let's see, another measurement. The spine, I guess it would be, is approximately 31 inches. Okay. The bolt to bolt measurement is 25 and a half. Could run it to 26. Like I said, it's a little random. Sorry, I'm not a very precise person when it comes to this stuff. The shoulder blades or shoulders, this piece is 15 and a half, 15 inches. So 15 and a half to 15 inches for that piece there. Okay. Beyond the bolt for the neck is about 5 inches more of the spine, the piece of PVC that makes up the spine. Comes out past the bolt 5 inches. Okay, we'll get to this in a minute. So the elbows, we've got a 45 and a 45. Okay. These pieces here between the elbow and the shoulder are 6.5 inches. Okay, so you got a 6.5 inch piece here. You know, you can run it 5. I'd run it about an inch shorter, just because this down here is taking up a lot more room. So I'd run this one about 5 to 6. This one about 6.5. Same here, same here. Okay, so you're gonna put a small piece of PVC in there to hold this joint to this. This is a piece of cardboard just for working here. That'll be a piece of, lumber underneath here. And then I plan on putting my unit up on top of a about 2.5 foot high tomb that I'm going to make, so he's hung out over the edge, peering. Maybe I'll have a body laying down on the ground for him to be dealing with. Okay. So we'll get to the wiper motor. Okay, the wiper motor is mounted on here with 2 U-bolts. Honestly, I'm probably going to change them to big worm clamps or hose clamps, depending on where you're from and what you want to call them. But typical hose clamp like you see on a radiator for a car. I think it'll tighten it up. This area down here is just wasted, and it's not pinching towards anything. So I think maybe it could eventually rotate out of there. So I'm going to probably take these off and put hose clamps on there. That's what I've seen other people do. And a friend of mine, Paul, has used them before, and it worked better than I think these will. Okay. And once again, no scientific explanation as to why this is 5.5 inches long. Okay. No science. I just experimented. Had a piece of aluminum with holes already drilled in it. I put it in there. Had a couple different holes in it already. I experimented with distances. You know, put in this, different holes here. This one seemed to work. I think everyone agrees the motion on there is the distance and everything seems to work really well. Okay, so this bolt's just a little too long, so it's up there. You can get a shorter bolt. It's about 3 inches. 2 bolts just squeezing it so the 2 nuts so the bolt doesn't turn. Lock nut. Keep this in place. Okay, I think more importantly than the 5-inch tube here is the distance between the axle, center shaft, and here. I tried it here, and the throw was too short. The side-to-side panning was too short. Okay? So, I will measure the distance between the shaft. You can see the distance between the shaft, center shaft, and this bolt and the center shaft is exactly 2 inches. This joggle isn't really going to be that important. I just bent it to make sure I used this piece that was already here. I cut a hole in it. It's just as joggled so that the nuts head doesn't hit anything over here when it's rotating around. So you can get that joggle in there yourself. But the distance between this hole and this hole is 2 inches. Okay, now the distance between this bolt, this pivot, and this pivot turns out to be exactly 12 inches. I imagine that geometry is important. This, if you want the same motion and everything, 12 inches here to here, 2 inches here to here. Okay? What was that, 5? 5.5. 5.5 for the crank arm rod. Okay, so 5.5, 12 inches, 2. That's gonna tell you how much throw you have, and how far to do. If you move this up to here, you'll get a little less throw. So I moved it back. I made 3 holes, and I decided that was the best one. So I think that's good. Like I said, any of these legs, the distances of these legs aren't really that important. I think if they were a little shorter and the shoulders were a little higher, I don't think it'd make a difference. It's level. Seems to be working. Okay, so the neck, which I think is probably the best thing, is the swaying of the head. Total lucky that it worked. I was going to put a reindeer motor up here and put a linkage down here and run this through here, okay? And then this came to me in a dream, okay? This is just a piece of 3/4 inch with an elbow. It's just sitting on there. Just sitting right on there. The elbow, there's a short, 1 inch piece of PVC in the middle, another elbow, and this piece comes up and goes into the foam head that is inside the mask. That's it. Okay, about a 4-inch bolt, I would say 4 inches. I didn't measure it. 3 to 4 inches. All right, this is stainless steel safety wire. Okay, we use that to work on airplanes, safety bolts and things like that. It's very strong. It won't fatigue break from bending. Obviously, since it's stainless steel, it'll hold up to weather. I imagine you could use bungee, cable, small cable. You could probably use, not everyone's going to have, obviously, this access to this stainless steel safety wire. I would say something similar is if you went to Home Depot or Lowe's and got a roll of the wire they use to hang pictures. You know, this is 32 thousandths. You could probably find something that thickness. You know, it just bends and tweaks and twists, so it's not gonna kink or anything. That's it. Screw here. You know, I messed with the distance. It looks like about 1.5 inches between the edge here to the screw. The wider you have them, the more side to side this will go. Okay? The longer the bolt here, the more side to side the head's going to turn. If you have a short bolt and you put the wire here, it didn't turn very much. And the closer I put it here, just for leverage reasons, it wasn't turning very much. So you want it as far out as possible, and that's what turns his head. That's what keeps the head centered as the body's moving. I think that's it. I think that's all the measurements and everything. Like I said before, I wing it. The only thing I've found so far is I just discovered it 10 minutes before I started this tutorial. If I take that target off the back of there, this whole thing wants to tip over. The front is heavy. The top is heavy. Those legs are not very wide. Maybe if I widened them, maybe it would help, but it didn't seem like it. I was running it for a few minutes before I started the video, and it wanted to tip over. So if you're going to put it on the lawn, maybe some sandbags underneath there, or stake the legs down. I'm going to run rebar up the middle. Whatever works for you, or if somebody comes up with a better idea of how to station here, make that more stable, then more power to you. If you can improve on this puppy, have at it. I'm glad everyone's enjoyed it. I think it turned out better than I hoped it would, and pretty happy with it. And that will be it. If anyone has any more questions, let me know. I'll do the best I can. Like I said, Spyder Hill. The joints, the bases, which are round, and these swivels or pivots. I'm not sure what they call them on the website. There's just a big hole right here. Smooth. 1-inch pipe fits right through it and just rotates freely. I think those things that were made for making PVC furniture, I think. I'm not sure. I'm pretty sure they make these themselves. And they're kick-ass. And you should buy a lot of them. And I think that's it, because now I think I'm babbling. Have a good day.